Thank you, Christine. Thanks for having me here. I think the slides are loaded up. So, hey everyone, Sandeep Nain. I'll be talking about security exposure management in API First World. Just to give you an introduction on myself, what I've done in the past. So, I'm currently VP of Security at Carta. I look after security engineering teams and trust engineering and so on. Prior to that, I was head of security partners at Facebook, now called Meta. Before that, I was the managing principal of HP45 for Asia Pacific. Um, all in all, I've been in the industry for almost 2 decades now. Started my career as a software engineer, but pretty early on, I moved into application security. Did a lot of pen testing and code reviews and architecture reviews and so on. And back in like 2009, 10ish, I started building application security programs. And when we started building those application security programs, the first thing that I was taught was security needs to reduce risk at low operational cost. So when you're building a security program, security organization, application security program, the focus is that you need to reduce risk, bring it to a manageable level, but the operational cost should be low. And we used to talk about like how it needs to balance of people and process and technology. Technology is used to find the assets and detecting the vulnerabilities. And by the way, I'm sorry for the fonts there. I think when I upload the slides, that changed a bit. So a bit of a misformatting there. So yeah, technology is used for identifying the assets and detecting vulnerabilities. But when it comes to using that information that these tools are generating, you need to have people in there and process in there to first people for triaging the vulnerabilities and finding what needs to be fixed and what not, prioritizing those and giving it to the engineers. And engineers will be fixing those. And when I say engineers, I'm talking about software developers. And then they need to process around that as well, like how it all needs to run. But as I grew or evolved in my career, I realized that yes, technologies are great when it comes to finding vulnerabilities. In fact, security industry has done an amazing job of building tools that can find deep vulnerabilities in all layers of a tech stack, be it the devices, be it infrastructure, be it our applications or software supply chain, and so on, you name it. But the reality is, like when it comes to processes and people, processes don't scale. As the company becomes big or their organizational changes or the tech stack changes, the processes fall apart. And when it comes to people, we just don't have enough people in the security industry. And these security engineers are pretty expensive. So when we try to leverage these security engineers to perform these actions, first, it's inefficient use of these security engineers because it's a very monotonous work of triaging the vulnerabilities, all the removing the false positives and so on. But also, then comes the finding the right engineer to fix the vulnerability part. That's also a waste of time when it comes to the time of security engineer. And finally, when it comes to fixing the non-logic security exposures in the code, it's a distraction for the engineers who are focused on building the features and shipping code and so on. So this whole people process technology thing, it fails 7 out of 10 times. So what do we need to do? We need to eliminate this manual operation overhead from the security exposure management. Now, it's a good concept to have, but how do we do that? And a few months ago, I was watching this presentation by Jeff Lawson, CEO of Twilio, and the presentation is called "The Software People." And in this presentation, he talks about 2 different types of software. The first one is the sensor software, which the whole purpose of sensor software is gather the data and present to the users. And the actuator software takes that data, converts that into an actionable intelligence, and then takes it to the end user who's supposed to perform an action on that actionable intelligence. Now, Jeff Lawson gives an example of Uber, like how Uber does it really well in their app. So when you open the Uber app, it shows you all the cars in your area, and it also knows your location. And when you say, I want to go to this particular destination, it finds a car for you, it brings it to you, sit in the car, you reach your destination, you come out of the car, and automatically you're charged. So you just click like one button, and you have gone from wherever you were, your source destination to the source to the destination, origin to the destination. In security industry, we have a ton of these sensor softwares that are really good at finding the vulnerabilities, as I mentioned earlier. But when it comes to the second part, we left it to the people and processes. So what we need is we need an actuator software. And if we need to build this actuator software, what would be the qualities of that? It should automatically triage these security exposures and identify the root cause. It should find who's the right person to fix these, the remediator, so to speak. And then it needs to offer that exposure remediation within the engineering processes. So if this is the need, let's look at like how we have evolved as software engineering industry. So these days, the current tech stack or tech landscape is ripe for this kind of innovation, in my opinion. Why? Because of the APIs. Now we have mass adoption of API-enabled cloud infrastructure. Everybody has moved or is moving towards AWS, GCP, Azure, you name it, and they have really rich APIs that you can leverage to not only know where your resources are, but you can actually edit those resources, modify those resources, and so on. Not only our cloud infrastructure, but also the dev ecosystem, the dev experiences. That has also matured a lot. So we are moving towards more standardized release management processes and technologies, GitHub, GitLab, and so on, and how you need to create a PR, which needs to be reviewed, and so on. It's really getting more and more standardized as we are becoming mature as an industry. And finally, not only the software development and the deployment, but also the security technology vendors are adopting APIs as well. So you pick any security tool these days, static analysis, dynamic analysis, software composition analysis, they all have rich APIs that you can leverage to interact with the data that these tools are generating. Now, that's the current landscape. So what we can do with this? So the first thing we need to do is we need to extend that sensor software and really enrich that information for the purpose of building this actuator software. So how do we do that? So we have security products, we have CI/CD, our release management practices and technologies. We have code repositories, we have infra. They all have the APIs. We bring that information and create and normalize it and create a graph-based database of all the resources that are there in our environment. So why do we need a graph-based database? Because we need to know how one resource is connected to the other. So what file is creating which resource in the environment? Now, this is nothing big as such, because it's essentially SBOM, software bill of materials. Now, if you don't know what software bill of material is, and as per the definition, Executive Order on Improving the Nation's Cybersecurity, which was released by White House in 2021, it's an accurate and up-to-date data provenance of software code or components and controls of internal and third-party software components, tools, and services present in software development processes, and performing audits and enforcement on these controls on a recurring basis. So basically what it entails is like all the entry points to the software, like APIs and serverless and so on, the third-party code, the open source, your dependencies, your commercial libraries and so on, the licenses, the data management, the code structures, the orchestration layer, the Kubernetes, the configuration of that, like how the software is being deployed, and the infrastructure, the Terraform files and Docker files and so on. Not only what the software entails, but also any kind of security risk in those software components too. For example, open source software security risk assessment, SCA findings, your static analysis findings, your infrastructure misconfigurations, or any kind of security tool coverage that is missing. Now, with this kind of structure, you can actually identify all those things because you're leveraging the two existing tools and tech stack that you already have. You're just consuming their APIs and extracting the data and storing that in a more normalized, more graph-based format, in a standardized format. So the next step, where actually rubber meets the road, is how do we convert this data that we have collected into an actionable intelligence? And to do that, the first thing that we're going to do is those security exposures that were identified by the security products, we need to perform auto-prioritization on those. Now, there are two things that we can leverage to perform that. The first one is the EPSS score. So EPSS is Exploit Prediction Scoring System. It is based on CVS score as well as the data that is available in the wild. So this organization collects the data, uses a CVS score, and gives a scoring to each vulnerability from 0 to 1. So if the higher the rating is, the more chances of this being an exploitable vulnerability. And reachability analysis is like, where does this asset, where the vulnerability is, how deep is that asset? Like, is there an attack path from entry point to this asset, which will allow an attacker to actually exploit the vulnerability? So when you have these two inputs, you can actually triage the vulnerability and see if it is an exposure or not. If it is an exposure, that means it needs to be prioritized. And based on the exploitability score, you can do the prioritization on there. Once you have that, the next thing is to find out the root cause. So security tools have a nature of finding for all instances of the vulnerability. So for example, if we look at CSPM, Cloud Security Posture Management Tools, they will show you all vulnerabilities in all the containers in your environment. So there could be 1,500 containers running in the environment, and if they all are vulnerable, it will show you 1,500 vulnerabilities. And if you give those 1,500 vulnerabilities to engineers or SRE team, they will be overwhelmed with the information that they have received. So what we need to do is, because we have this technical context of like how each of the resource is created based on the structure that we have created, the graph that we created, we can identify which file actually created which container. So there could be 1,500 vulnerable containers, but there could be like just 5 Docker files that need to be modified. So once you have the prioritized vulnerabilities, you can find like which files need to be modified. And when you have files, and once you have those files, you need to know who is the best person possibly to fix this vulnerability. How do you do that? Of course, you can use resource tagging, which will help you in which team is responsible for it, or we can perform things like git blame on identifying who has actually touched this file most recently or most of the time, to find who's most probably the right person to fix it. So when that happens, we have pretty much like we are all the way to fixing it. And how do we actually fix it? Now, in 2023, I think every presentation needs to have some sort of like LLM component to it. And here, this is a pretty good use case of using LLM for generating the fixes. So I've tried it myself multiple times, and it's actually works really well when it comes like, hey, this is a file, this is a problem in this file, I need to fix it, suggest me some code fixes. So 60 out of 100 times, it gives you a really good fix for the vulnerabilities. So you can use generative AI, Codex, GPT-4 to create those code fixes. And once you have that, you can actually send that to the remediator, the person that you identified as the one who is most likely to fix it, via Slack message. So once it goes to Slack message, you don't want people to just change things without going through the process. So what you really want to do is, when people look at the suggestion, they need to make a call on like, yeah, this seems like a right way to fix the vulnerability. If not, they can reject it. And when they do that, it creates a PR or MR depending on GitHub or GitLab, and to create the to update the asset. Now that goes to your repository, from there to staging environment, test environment, pre-prod, prod, the process that you have in the organization. So basically, you're meeting the engineer where they are. So by doing that, not only you were able to consume leveraging the APIs, you were able to understand where the vulnerabilities are, but you really removed the manual operational overhead that was there in the process of triaging it, finding the right person, and then fixing it. So yes, APIs enable security reduced risk at low operational cost. Things that were very manual in the past are becoming more automated, and they can be automated in this manner. It removes the pain of security teams and engineers, and also provides immediate value from the security products as well. I personally believe that the direction that we are heading into, information security in a few years from now will become more of a governance function, and the security decision making will become more and more distributed. And what I mean by that is like the SRE teams will be able to find the vulnerabilities and fix the vulnerabilities in the stack that they own, and the software engineers will be able to find and fix the vulnerabilities in the stack they own, whereas information security will make sure that this thing is actually happening. But to enable this future, we need these two things. One is the elimination of operational work, and we saw how leveraging APIs and building solutions that are taking the data and converting it into SBOM format actually helps in reducing the operational work. And also, we need to ensure that we need to minimize the friction for the engineering, the learning curve for the engineering as well. And tools like this, which are making it easy and cheap for engineers to find and fix the vulnerabilities, will be really useful in building the future too. It will provide the maximum ROI from the security tooling as well. With that, thank you for joining me. I'm happy to answer any questions that you may have.
Yeah, thank you, Sandeep. That was a very, can you hear me okay?
Yes, I can. Yes.
Okay, sorry, I just realized I hadn't plugged back in my headset. Wanted to make sure my mic was working. That was a really informative session, and I just appreciate that all of our sessions today, but especially this afternoon's sessions, are really very practical, hands-on based approaches. I'm curious, is this approach that you've kind of laid out and the methodologies, is that something that your team at Carta is embracing? And have you seen any maybe like pitfalls or have tips or tricks for how to, if you're shifting to this sort of a model and you haven't been there before, are there things that people can do to ease that transition and to reduce any sort of friction?
Yes. So yes, at Carta, we are building tooling around this. So we have already built tooling around auto prioritization using EPSS score and reachability analysis. And in the industry as well. So knowing how hard it is to find good security engineers, and we need to be more and more efficient and more lean as we move forward. Automation comes in very, very handy. And this actually helps us in not only hiring the good engineers, because now they can actually focus on more important work, but also like increase our, maximize our ROI from the tooling as well. And I've not seen any really commercial tools around this yet, but the building blocks to build these tools are available now, and I'm seeing more and more innovation in this area.
Yeah, it's an exciting area to watch. You mentioned, we've got just like 1 minute left. I was just gonna say that you mentioned some large language models, and yep. Can you expand a little bit more about that and kind of how you guys are leveraging that and what you've seen, and are there, I know that some of that's in training the model itself, right? So how do you go about doing that so that the value?
Sure. So the good thing about LLM for creating the code fixes or creating the code is that we have technologies like Microsoft Copilot, GitHub Copilot, which is built on a ton of code in GitHub itself. So we are trialing that in the company at the moment, but and Copilot is becoming more and more popular as because it's integrated with the tooling and so on. And the Codex, which is also part of GPT, GPT-4 came up with a like advanced version of Codex, which is also really focused on providing good code snippets and code fixes, so and code generation. So I believe leveraging that will be like really, really boom for us. So not only for Carta as a company, but I'm talking about the industry as a whole. So I think I'm hearing a lot of good things about Copilot and Codex, and people are seeing increase in 30% of when it comes to productivity.
Yeah. And you mentioned Slack in there, but I think that kind of bears mentioning again as well. Just integrating all of this into the existing tooling and how developers, their way of working today already, and the tools that they're working in and within their software development lifecycle. I liked that. I appreciated that about your talk as well. I'm just going to check really quick and see if we've got any other questions in the comments. I think we hit all of them. Oh, hold on. Is there any reference to integrate with the scoring system? Sorry, that we have one more question.
So if you go to EPSS.org, it talks about what this scoring system is, how it works, and APIs around that as well.
Okay, and I just put that in I dropped that into the chat, the URL that you just mentioned. Go ahead, sorry, I didn't mean to interrupt you.
I was just saying that we are using that extensively in our tooling inside my organization.
Great. That was an amazing session. Thank you so much, Sandeep. And if you are just joining us or are catching in up late, all of these sessions will be available on the API Days YouTube channel. It's at API Days. So give it a couple of days and these will all be up there if you missed anything. And if you've got any other questions for Sandeep or any of our other presenters, feel free to drop them in the comments and we'll make sure that we route them to the different presenters and get you an answer. Thank you, Sandeep. Have a great rest of your either evening or day or afternoon.
Thank you, Christine. Thanks for having me here.
Awesome.